is the concept, that is the what is plastic, and how it will be manufactured, and plastics. You can see the what is plastics and plastics and powder methods. And coming to course, advanced materials and presented by Dr. Bhagat Sheikh, Professor Ramchandra College of Engineering, and developed by Jawaharlal Nehru Technological University, Kakinada. And first of all, we will see what is plastic. Then we will see powder metallurgy also. First of all, we will see the concept how the plastics and how the manufacturing process is involved. What is plastic? Plastic belongs to the family of organic materials. What is organic materials? Organic materials are those materials which are derived directly from carbon related. How it consists of carbon chemically combined with hydrogen, oxygen, and other non-metallic substances, and their structures in most cases are fairly complex. And synthesis includes a large group of solvents, adhesives, synthetic fibers, rubbers, plastics, explosives, lubricants, dyes, soap, and cutting oils, etc., which have no biological origins. From these, plastics and synthetic rubbers are termed as polymers. These plastics are classified into two types related to, because these plastics which causes due to the thermoset or causes thermosetting or causes them to soften and melt. The two types of thermosetting plastics and thermosetting plastics undergo a number of chemical changes on heating and cure infeasible and practically insoluble articles. The chemical based or chemical changes is not reversible in these thermosetting plastics. These plastics do not soften on reheating and cannot be reversed. And coming to thermoplastics, soften under heat, harden on cooling, and can be resoftened under heat. Thus, they retain their fusibility, solubility, and capability of being repeatedly shaped. And coming to the different properties of plastics, it is a mass production plastic substituted for ferrous metals, allow the production cost to reduce by factor of 1.5 to 3.5, and for non-ferrous metals has a factor of 5 to 20. Depending upon different properties, it has the good damping capacity, good surface finish of the product. It's having high heat and electric insulation of plastic permits them to be applied in the radio and electrical engineering industries as a dielectric and as substitute for porcelain, ebonite, shellac, mica, natural rubber, etc. And it having good chemical stability when subjected to the action of solvents and certain oxidizing agents, water resistant, gas and steam proof properties. It's having the enable plastic to be used as valuable engineering in the automobile and tractor, shipbuilding and other industries. How different parameters of some plastic materials having? Materials generally we know the acrylonitrile, butadiene, styrene, having applications usually for the housing appliances, safety helmets, and the different interior of articles. And different residual, different nylon, polycarbonate, low density, polyethylene. These are the different parameters. Polypropylene, polystyrene. Polystyrene generally used for manufacturing applications of toys, food packaging, coffee cups, hangers. Coming to epoxy related is applications are encapsulation of electronic components adhesives. And coming to phenolic having tensile handles and terminal board frames, electrical switches, housings. And how the processing of plastic takes a major role and how it is manufactured. Pallets, granules, powders having liquid paste, reaction, injection molding. Extruded parts are like related to extrusion, injection molding, rotating molding, or rotational molding, or structural foam molding, compression molding, transfer molding, casting, foam molding. These all are will be manufactured with the extruded parts and how the fibers and how this will be linked to solid state. Coming to sheet, having the thermoforming tube, having the blow molding, blow form. And coming to fibers, fiber reinforced sheet or laminated sheet, vacuum bag forming, pressure bag forming, and layer layer. These all are manufacturing process in order to have the different materials like plastic and how it is processed, how pulverization also taking place. And these are the different process like extrusion, injection molding, texture forming, foam molding, blow molding, rotation molding, thermoforming, compression molding, transfer molding. Generally, casting are these all are having different characteristics. Extrusion having solid or hollow complex structure. Injection molding is mainly useful for the complex shape of various areas, involves various production rates, costly tooling, dimension accuracy. In coming to already we know that blow molding having hollow, thin wall parts, bottles of various sizes, like unique paraffin bottle or PET bottles. We can manufacture for various sizes and production rates, relatively low tooling cost. These are the different concepts and how it will be useful and how it will be applicable for different industries. These are the example parts how it will be manufactured with respect to plastics with the help of powder metallurgy. And we are discussing about the powder metallurgy of new concept. Generally, if this powder metallurgy having powder production, blending or mixing, compaction, sintering, and finishing. Sintering is heating. These are the five types involved, five steps involved in this powder method. Taking of the powder is blending or mixing, and compaction in order to shape, size. After that, heating or sintering. Finally, we can finish with the help of powder method. We can observe the image of the figure. We can understand clear picture of the powder production. In this powder production, how the melting and how the nozzle taking place and what are the different water or gas flows involved. How one-dimensional activator or chemical decomposition is having irregular rod-like chemical decomposition, mechanical communication, and how two-dimensional dendritic, electrolytic is mechanical communication. And coming to three-dimensional, like spherical atomization, carbonyl precipitation from the liquid, how rounded atomization, chemical decomposition takes place, how the angular mechanical disintegration, carbonyl, and how this atomization, chemical decomposition, reduction of oxides, how this atomization, the most common, others chemical reduction of oxides, electrolytic deposition, and how different shapes produce will affect compaction processing significantly. And coming to blending or mixing, we can use master alloys, most commonly are elemental powders, or we will build up the alloys. This is also called as master alloys or with the normal alloy ingredients. These elemental or pre-alloyed metal powders are first mixed and with lubricants or other alloys also. These all are additions to produce homogeneous mixture of ingredients. These are the concepts involved in this blending or mixing. When we are mixing initial stage, it will be done by the metal powder producer or the powder metallurgy parts in order to manufacture. These all are related to the particles are blended. And coming to compaction. What is compaction and what are the different conditions satisfying concept compaction is very, very important. You can observe this figure. This is the top punch, this is the filler shoe, and this is the compacted part. This shows the final shape or size of the compacted part. Is usually compaction shows usually gravity filling the active cavity at room temperature. It produces green compact like size, shape, finished part almost. It's not as strong as finished part handling concern. And coming to friction between particles as measured. These are the megapascals in the mole under 2 maximum 100 megapascals. This shows a clear picture of the compaction with respect to different dimensions, length or diameter. And coming to isostatic pressing, this is the manufacturer isostatic pressing, how the industrial used, how isostatic pressing will be called. You can observe the machinery used for isostatic pressing. It removes for charging full mold, first figure shows it removes for filling mold. It's in between center having the pressurizing fluid and ejector. Because isostatic pressing plays a major role because of friction between particles, it will be applied for the pressure uniformly from all directions. It having the wet bag left and dry bag right. And coming to sintering or heating, already we know that parts are heated to 80% of melting temperature. How it will transform compacted mechanical bonds to much stronger metal bonds. How many parts are done to be at this stage will require additional process. You can observe how heating takes place and how manufacturing parts product will be finished. This is the sintering conditions respected to density, strength, ductility. Finally, parts are drastically affected. You can observe the different structures of being compact, next formed, pore size reduced, fully sintered. This will be sintering time with respect to 0 to 150 and coming to dimensional die having the maximum temperature is 13 15 degrees centigrade. These are the main sintering and finishing shows the plastics with respect to powder metallurgy. This is the new concept involved of the processing of the plastics and plastics in the powder metallurgy.